Welcome to another exciting show of AP Calculus, the show that prepares you, yes, you, the calculus viewer, for the AP Calculus exam, which is in how many days? 14 days! 2 weeks! 2 weeks from today, it's all over. You know, it is time to just relax and worry about your other AP exams and all that stuff. So what we're going to do today is go over free response problems that you may or may not know how to do, but the point is going to try to show you how to earn points. The point is to show you how to earn points on the free response part of the AP exam. The phone number is 972-925-3123. Call in for a question or two. We have much exciting stuff today. We're going to start out with hopefully a relatively easy question and show you a couple different ways to do it. And we have the Jaguars on the line. Who is this?
Suthama.
It's Suthama, right?
Yeah.
How you doing?
Pretty good, I guess.
Why just I guess?
Huh?
Nervous. Why are you nervous?
Because this is my second time calling. I haven't called in a long time.
Hey, are you coming this Saturday?
Yeah.
All right. So don't be nervous. Don't be shy, because it's all part of the try. That's pretty stupid. Okay, here we go. Suthama, Jaguars. Okay, here we go. No problem. No pressure. See, there you are.
Look at that girl.
Hey, you know, that's, I don't know, show a little shoulder there, Suthama. You know, that's,
What's her name?
What's that?
I'm kidding.
Okay. The y equals 1 over square root of x for x equals 4 to 9. I think there's a problem from 1997, somewhere around there. Find the area of R.
Integrate.
Okay, integrate. What do we want to integrate?
Rewrite the 1 over square root of x to the negative 1/2.
Okay, and?
From 4 to 9.
Okay, from 4 to 9. Okay.
dx.
dx. Okay, what do you want to do from there? Well, that's horrible.
Rewrite.
What's that?
Rewrite.
Rewrite what?
Please come to the main office.
Tell Melina not to do the announcements during my show, okay? That's really rude.
Huh? Nice. What were you saying?
I don't know. What do you want me to rewrite?
X to the negative 1/2.
So it's x to negative 1.
Integrating from 4 to 9, x to the negative 1.
Okay, and then what do you want to do?
dx. Bump it up and divide.
What's that? Bump it up and divide? Is that a Jaguar term? Bump it up and divide. I like that. Is that Ms. Brzezinski talking? Is that her lingo?
Yeah, that's her language.
Bump it up and divide.
Bump it up and divide.
Hey, that's
plus 2 over
PG.
2.
Okay. So it's x. What do I bump up? What do I do?
Bump up the negative 1/2 to 1/2.
Okay.
Divided by 1/2.
Okay.
Then run it from 9 to 4.
Okay.
I mean 4 to 9.
It's okay. I know what you're talking about. What do I do from there?
You could bring up the 1/2 from the bottom up to 2.
Very good. So it's 2, and what's x to the 1/2?
Square root of x.
Okay.
From 4 to 9.
Okay, and then what do you do?
Plug it in. Okay. 6.
So it's 6 minus
2. 4. 2 times 2 is 4.
Okay, so it's 6 minus 4 is 2. Okay, let's talk about the AP exam. This was a calculator question. I probably should preface it with that. This was a calculator question. So what you do to earn the points, it's important to write the integral. And you could actually do it out like this, but you could actually do it in your calculator, do the integral from 4 to 9 in your calculator like this, and then just put down the answer. So if this is a calculator free response, this year they have calculator free response and non-calculator free response. All you'd have to do is write this and then put down the answer, and you get actually all the points. Okay? You can actually do it out the long way, but if you have a graphing calculator, this is your friend when you have a definite integral. Okay? So, and do you know how to do the definite integral in the calculator?
Yeah.
Okay. So what you would do is you can just do that, and I would actually save time by typing that in the calculator and coming up with the answer instead of doing it the long way if it was a calculator part, okay? Isn't that exciting?
Of course.
That wasn't so bad, right?
Nah.
Okay. Woo! Jaguars! Okay, call in again.
Okay.
Hey, Jake?
Hey, Mr. Fleischer.
Okay, you know what? I really wanted to save the hard problems till later, but
Okay.
I'm not going to. I'm just
Okay.
going to give you part A. And everybody who's ever watching, this is a really hard problem, but I wanted to do there's a point to this problem, and I want to show you what this is. That if you don't know how to do it, what can we do? When you see a problem that is really, 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 really hard, what can we do? At time t, t greater than or equals 0, the volume of the sphere is increasing at a rate proportional to the reciprocal of the radius. At time t equals 0, have you seen this problem before, Jake?
I think I've seen something similar to it.
Okay, the radius of the sphere is 1, and at t equals 15, the radius is 2. The volume of the sphere is that. Find the radius of the sphere as a function of time t. Now, I'm going to give you a second to take a look at that, but I'm hoping, Jake, that even you, the great Jake Meyer, is going to struggle. No, even you will struggle with this.
Okay.
I'm trying to do the proper English.
So you set up an equation that the volume is equal to the reciprocal of the radius.
Right. So what?
So it's v equals 1 over r, or is that the reciprocal?
Okay.
1 over r.
What is equal to 1 over r?
Oh, just a minute. Oh, it's dv. The
Right.
rate
What
of the
does
volume.
it say? I mean, so what is equal to? I mean, tell me. What does proportional mean? What does proportional mean? When you see the word proportional,
It means multiplication.
Right. It means a constant times something.
Oh, it's k. Yeah.
Right.
It's k times 1 over r, and then you have to integrate. Right?
Right.
You have dv over dt, because it's increasing at a rate. The volume is increasing at a rate. So that's a derivative, right?
Right. Right. So what would you do?
Okay, so you have dv over dt is equal to k 1 over r, but then
So what's equal to 1 over r? Say that one more time.
dv over dt.
Very good. So dv dt is equal to k over r, right?
Yeah, k over r. Sorry.
Okay.
Yeah.
Now that's actually pretty hard. Now most people wouldn't get that, but what I want to show, actually keep working the problem, and then we'll go from there. Actually, this is pretty hard, but actually, you know what?
Because then you
Hold
don't have the right-
on. We just had a student walk into the studio here. Hold on for a second, because this is a really hard problem. So, Jane, when you see this problem, what could you possibly do?
Well, first you know that it's one of the problems where it's talking about the way that the size of the thing changes.
Okay, so what's something that you would know to do?
You're going to have to take the derivative, right?
You're going to have to take the derivative. Okay, great. So we'll get back to that. So if you see a problem like this, and this is really hard to set up, but somewhere in the problem, you know you're going to have to take the derivative of this, and you could tell it's a relative rate problem. So
Okay,
somewhere in the problem, we're going to need to take the derivative of that, and that would be worth 2 of the 9 points. You may not know anything on how to do this problem. I know, Jake, I'm going to let you do this in a second. But somewhere in the problem, and Jane, what is the derivative of v equals 4/3 pi r cubed?
4 pi r squared? No.
Right,
Yes,
it's 4 pi r squared times dr dt. Okay, so dv dt is equal 4 pi r squared dr dt. So somewhere in the problem, I don't know if it's part A or part B, but somewhere in the problem, if you just write that down, you're gonna earn points. If you just write that down, you're gonna earn points. Okay, Jake, I'm gonna be quiet and let you finish the problem now.
Okay.
All right.
Okay. Well, I think you sort of stuck. I'm sort of going blank here.
Okay, if dv dt is equal of
You
k
said
over r.
R equal to solve for r on the
Right
other
now,
side?
Jake, let me tell you something. You would have 20 minutes to do this problem. I'm
Oh,
saying, and
okay.
you have to. I'm giving you 2 or 3, so don't. Somewhere in the problem, if you are stuck, and I gave this the hardest problem that I picked
Oh,
out
you
today.
plug it in and you find out what dr dt is.
Well, right. We know dv dt equals kr, so we could set this equal to this. Now, in this problem, you
Oh,
earned a
okay.
point if you set that.
Yeah.
2 points if you got that. Another point if you actually set them equal to each other. Since dv dt is equal to k over r, 4 pi r squared dr dt is equal to k over r. We're still nowhere near out of the woods yet. It still gets very hard from here. Our
Yeah.
goal is to solve for r. When you see this problem, Jake Meyer, how would you solve for r? What do you do when you have
Well,
a differential
you have to
equation?
get rid of the dr dt, right? So you have to integrate.
We have to integrate. So tell me what to do. Very good.
Okay, so on the left side, would it be Okay, first you have to put all the r's on the same side, right?
Excellent, excellent. You have to put all the r's on the same side because...
So you multiply by r and you get 4 pi r cubed is equal, 4 pi r cubed dr dt is equal to k.
Okay, I'm going to make it k dt.
K dt, oh yeah, because, yeah, dt. 'Cause
So
you
we
have
got
to-
all the r's
yeah,
on one
okay.
side, all the, right? This is
Okay.
a very hard problem, but my whole point of the show today is what can you do to get problems? Always write down something. I know that you're going to finish this problem, but always write down something. When in doubt, take the derivative and set it equal to 0. But in this case, a related rate problem, that's a good
Yeah,
way
related
to...
rates.
Okay, now what do we do from here, Jake?
Okay, now you integrate, and so you, well, actually you can, on the left side, you can go ahead and take the 4 out of the, can you go ahead and do that? Take
Okay.
the 4 out and then integrate pi r squared dr.
So it's 4, I'll
Yeah.
get that out to 4 pi and make
Oh,
it r
okay,
cubed.
yeah, because they're both just constants.
Okay,
And then and so on the left side, it's going to be 1/4 r to the 4th,
right, 1/4 r to the
or r to the
4th
4th
times
over
4.
4. And so the 4's cancel out, so,
So
it's
it's just
pi
pi r to
r
the 4th.
4th, right? And the other side is k is just a constant, so it'll just be t,
kt
kt.
plus c,
Yeah.
right?
So then now you use your the stuff to solve it. You plug it back in. The
At
stuff that
at
you
time
know
of
to
0,
solve
the
for t.
radius is 1.
Yeah, and so when the radius is 1, the time is equal to 0. And so it'd be
Pi
pi
is
is
e-
equal to c.
Pi is equal to c, right?
C is equal to pi.
So therefore, we have pi
So then you
r
want
to the 4th is equal to kt plus pi, right?
right, and then you solve for t because you want it as a function of time, right?
Right, you want to solve, it says find the radius, so you want to
Oh, the
solve
radius.
for r.
Oh, okay.
But we
You
got to solve
R.
for k actually too. And so what we'd
Oh,
solve for
okay.
k, it says when t is 15, the radius is 2.
So then you just plug it in.
So
and
it's 16 pi is equal to
15K
15k plus
plus
pi.
pi.
Subtract pi, you have 15 pi is equal to 15,
K.
K.
So k is equal to pi.
k is equal to pi, right. So k is equal to pi.
And then
And
you write
then-
out your
Right, so you plug there in, so you got pi r to the 4th
yeah.
is equal to pi t plus pi. And then to solve for r, you divide by pi,
And so it's t plus 1.
so it's t plus 1, so r is equal to the 4th root
4th root
of t plus 1. The
Okay,
point on this
that's a nice
problem,
problem.
yeah, Jake, this was 1992, number 6, I think. But
Okay.
Jake, you know, the point of this problem is not, there are going to be questions on there. You only need about a little over half the free response right to get a 4 or 5 on this thing. There are going to be problems where they want to stump just about everybody. And the key to doing well on the exam is to know how to earn points. Take derivatives, take integrals, and just try to set up what you can. But once again, Jake, you'd have 20 minutes to figure that part out, okay?
Okay.
Hey, great job. Call in again.
Okay.
Kevin Gonzalez!
Hello.
Hi, is this, I got your picture.
Huh?
I got the picture you made for me.
Oh yeah, I remember that.
Okay.
Would
Hey,
it be okay if I asked a question off of the BC review sheet?
well, I hope I can do it, yeah. Sure.
It's just a limit question. So.
Just a limit question. Is this problem number 17 on the BC review sheet?
Yeah, that one.
That one, okay. Okay, the key is that whenever you have a limit, excuse me, whenever you have a limit and you have 1 plus 0 to the infinity, if, limit of something. This is just for the BC people out there. Whenever it's going to be e to the something, and the formula is the limit as x goes towards infinity of 1 plus x over n to the nth is equal to e to the x. Okay?
Okay.
So if you had a simple problem like this, limit as x goes towards infinity of 1 plus 3 over n to the n, what does that equal?
E to the third.
Very good, e cubed. So now when I gave you this problem, limit as x approaches 0, I think it was 1 plus 3x to the cotangent x, is that right?
Uh-huh.
This is, when you plug in 0, you get 1 plus 0, and cotangent's cosine over sine. So that's, the sine is 0, 0. So this is 1 plus 0 to the infinity. So you know this is an e thing,
Okay.
okay? You know this is an E thing. And from there, what I did, I think you can rewrite this in terms of E terms to make this 1 plus 3 over x, which is still 1 plus 3 over infinity, which is 0, raised to the infinitieth power. And that is now you have 1 plus 0 to the infinitieth? 1 plus 0 to the infinity, and now you have the same thing as E cubed. I think it may have been minus.
It was plus.
Yeah, you know, there was a problem. I'm going to have to show it to you. Kevin, there was a problem, I think, on the 1993. See if Miss Arthur has a 1993 BC exam. It's somewhere around problem number 43, I think.
Okay.
And somewhere around there. I may be off a little bit, but I'll show. Remind me, I'll have it in my... Are you coming this Saturday, Kevin?
Probably, yeah.
Probably? What do you mean probably? What's that? I'll show it to you what I'm talking about, and we'll work out a problem that's a little bit different than this.
Okay.
Okay?
Thanks.
And hopefully you'll see what I'm talking about.
Okay.
All right. Do we have another? Who's this?
Hello?
Hello?
Hello, Mr. Fleischer. This is Valina.
Valina Brown?
Yes, sir.
How you doing?
Pretty good.
Hey, are you coming to the administration building tonight?
Sir?
Never mind. Okay, just ignore me. Is this great, Valina Brown? Hey, what's your math SAT score? 750? Did you retake it?
No, I haven't retaken it.
Okay, no pressure there. I tell you that you're already what your SAT score is. Valina Brown, Carter Cowboys. What's going on? Are you studying hard for this thing?
Oh, yes.
Oh, yeah, that doesn't sound real convincing, Valina. Okay, hey, we're going to give you a hard problem.
Ooh,
Okay, we're going to give you a hard problem. It says, let f be the function defined by natural log of 2 plus sine of x from pi to 2 pi. Find the absolute max and the absolute min value of f. Okay.
So I'm going to find the absolute maximum and
Yeah.
the minimum value, the absolute max
Yeah.
and min.
Right, no calculator.
No calculator.
No calculator.
Okay, so first I have to find the derivative, right? Instead of
Okay,
equal
so
to
that's a
zero.
good point. You know, that's great. What you just said is beautiful. You know something? You know what that does? That brings us a happy face. Okay? Because that is great. You just said the magic thing. Even if you're really like stuck on this, you know, when in doubt, what do you got to do? Take the derivative, right?
Yeah.
And you'll get some points. So what is the happy derivative?
I'm sorry?
What is the happy derivative?
The happy derivative is cosine of x over 2 plus sine x because it's a natural
She is in
log
fuego.
problem.
There's no stopping Valina Brown. Where are you going to college next year?
Texas Christian.
All right, TCU?
Yes, sir.
What are you going to major in?
I'm not sure yet.
Why don't you be a math teacher? What?
No.
Valina, why not?
I was Miss Blackwell on senior teach day, and I decided that I didn't want to be a teacher.
You know what, Valina? I think you'd be a great teacher. I'm looking for a picture of you.
I'll teach on the side. No, don't find the picture.
I have Kara. I don't have you. Okay. So Valina, actually, you should think about it. It's a great profession. You'll really like it. And I think you'd be great at it. Okay.
Thank you, Mr. Fleischer.
And we'll help you. No, we'll help you. We'll help you get a job. Well, Miss Carter, when Miss Blackwell's ready to retire in about 15 years, you can take over her job.
Miss Blackwell is never going to retire.
15 years, Miss Blackwell.
Carter forever.
Miss Blackwell. Okay, here you go, Valina. What do we do now? We found the happy derivative.
We have to set the derivative equal to 0 to find our critical numbers.
Okay, so what's the definition of a critical number, Valina? That's a good point. Definition
The
of
definition, when f prime equals 0,
or
4 does not exist.
right. So who's screaming in the background?
Claudia!
Is that Miss Branch?
Claudia Green.
Who? Okay, hey, Valina.
Yes, sir.
We're on national television, Valina. Okay, it's right. So we got to set the numerator and denominator equal 0. From pi to 2 pi, when does cosine equal 0?
When does cosine equal 0?
Yeah.
At pi, is it pi? At pi over 2.
What's the cosine of pi?
1.
Cosine of pi is what?
Negative 1.
It's negative 1. And what's cosine of 2 pi?
Cosine of 2 pi is 1.
Right, so it's in between pi and 2 pi. Cosine of x is equal to 0 at x equals 3 pi over 2.
That
Okay?
x equals 3 pi over 2.
And now, what about this one? When does this equal 0?
2 plus sine x?
Yeah.
Well, we would have to solve that.
What do we know sine of x can be between? What and what?
Sine of x can only be between 1 and... 1 and negative 1.
Very good. So if the smallest this could be is -1, then this is always going to be positive.
Yes, sir.
Right? So that'll never be 0. So the only critical point is 3 pi over 2.
Okay.
So how do we find the absolute max and min?
The absolute maximum?
Yeah.
Well, first we're going to see, we could make a number line and do the first derivative test.
Let's do the first derivative test. That's fine.
And find out whether it's a max or a min. Yeah.
Okay. So what number do you want to plug in between pi and 3 pi over 2? We know the
Well-
denominator is always positive.
Pi is less than it, right? And
Yeah,
then
that's
2
-1,
pi
and that's 1, and that's 0. So you know that that's negative and that's positive. So what do we know 3 pi over 2 is? What is that going to be, a minimum
it's
or
going to
max?
be a minimum because this first is decreasing, then it's increasing.
Right, and very good. And basically, when you show this, this proves two things. This proves there's a relative min. This little number line thing proves there's a relative min at 3 pi over 2. And also that means if all the graph does is go down then go up, it's an absolute min too, right?
Right.
If all the graph does is go down then come back up, that's where there's a relative min would be
Okay.
where there's a absolute min,
So
correct?
we already know our absolute min.
Well, we know at the x value, to find the y value, we'd have to plug it back into the original equation.
Yes, sir.
We'd have to plug 3 pi. What's sine of 3 pi over 2?
Sine of 3 pi over 2,
Yeah,
-1.
it's -1, right. So it's 2 plus -1, which is 1. The natural log of 1 is equal to what?
0.
It's 0. So the minimum, absolute minimum's at 0. What about, how do we find the absolute max?
Absolute max,
Yeah.
we would have to sub in both pi and 2 pi and see which one
Excellent,
is larger.
excellent. And you know, this is called, what we're about to do now, and then we'll show you how to earn points on this thing. What we're about to do now is called the closed interval test. And you got pi, 3 pi over 2, and 2 pi. When you want to find absolute, you just plug in the endpoints and the critical points, and you plug them into the original equation, which is natural log of 2 plus sine of x. When you plug in pi, sine of pi is 0, so this is natural log of 2. This is 0, and when you plug in 2 pi, it's also natural log of 2. So the absolute maximum is the same. Absolute maximum is natural log of 2, and the absolute minimum is 0. Okay?
Okay.
So therefore, this is an apps min, and this is the apps max. Now what you can do, there's actually two. The absolute maximum is natural log of 2, and it occurs at 2 places.
Okay.
To get the points on this, Valina, first you have to do is find the derivative, and then you'd have to find the critical point. This would be worth 1 point. 3 pi over 2 is worth another point. Are you there?
Yes, sir.
And then what you need to do, you could do one of two things. You could show this closed interval test and just write down this, and it'd be full credit.
Oh, okay.
All right? And to label your absolute max and absolute min, and then write down absolute max is natural log of 2, and you could say it occurs at pi and 2 pi, and absolute min is 3 pi over 2. If you do the first derivative test, you could say that the apps min is f of 3 pi over 2, which is equal to 0, and then write apps min. And for your apps max, you would have to test both of these and realize that they're the same thing. They're both equal natural log of 2. All right?
Okay.
Isn't that pretty exciting? Did I depress you?
Oh, no.
Okay, you did a great job.
Thanks.
The enthusiasm in your voice sort of wandered as I was talking.
Oh, no, I was paying attention. I was writing down everything you were
You're writing down. That's a good thing. All right. Hey, great job, Alina. Call in again. Okay. Are you going to be there Saturday?
No, sir.
Why not?
I have to be out of town Saturday
Be out of town for what?
for a funeral.
Okay. All right. Call in again, all right?
Okay.
Mary,
Hi, Mr. Fleischer.
how you doing?
Fine, how are you?
I'm fine. Thanks for asking. Ready for a problem?
Sure.
Are you excited?
I guess.
Are you ready? Are the girls' softball team? They're playing now, right now, aren't they? Playoffs?
They're playing tonight.
I thought they played at 4 o'clock.
7:30.
7:30. Wow. Okay. Yeah, they're pretty good. You know, they beat Hillcrest pretty badly. You know. I know. Pretty depressing. Okay, Mary.
Okay.
Okay, this is no pressure.
Okay.
No pressure. I'll let you read it since.
Okay, so what you need to do is you just need to take the integration of the acceleration function.
Ooh. Say that again. That sounds good.
Take the integration of the acceleration
So you
function.
know what? That's excellent because you know one year, you know what they did, Mary?
What?
They gave credit if you just wrote down this.
Oh, wow.
You know that even if you messed it up. So if you knew that the velocity was the integral of the acceleration, you actually got that. So that was good. And then it's the integral of 6t minus 18. And what is the integral of 6t minus 18?
It's going to be 2t squared minus 18t plus c.
So it's 3t squared minus 18t plus c, right?
Right.
And then what do you do?
Then you know your velocity at time 0 is 24.
Okay.
So plug in 0 and set it to 24.
So we got c is equal to 24, right?
Right.
Okay, and so just real quickly, I want to show you how you would get points on this thing. You would get sometimes, and one year you'd get a point if you just wrote down this. You would definitely get 2 points, or 1 point if you actually showed that, another point if you solved for C. Okay?
Okay.
Okay, great job, Mary. Calling again.
Thank you.
You're welcome.
Bye.
Cindy McCone!
Hi, Mr. Fly.
What's going on?
I was just wondering, can I ask a test-taking question?
A test-taking question, sure.
We wanted to know when to say absolute and when to say equal. Like, approximate and equal, like for Taylor series or Riemann sums and stuff.
Well, Riemann sums are always an approximation unless it's a linear function. Okay, but if it's linear and you're using a midpoint Riemann sum, I believe that's always going to be, well, if it's linear with a slope of 1 at least, it'll always work out like that. If anytime you're using Riemann sum, just use approximation. You're approximating trapezoidal rule, Riemann sums, those approximate the area. Okay? The Taylor series approximates, this for the BC students, approximates the transcendental function. You're writing a polynomial function that is approximately centered around a certain point at a certain point what the transcendental or the function that you're trying to take, it will be the approximate value. In other words, if you graph like e to the x squared and then write out the Taylor series for it and graph that around x equals 0, they're going to look exactly alike. I mean, they're going to be really close. At x equals 0.1, it'll be an approximate value if you plug 0.1 into the polynomial instead of into the e to the x squared. Did that make any sense?
No, that makes sense.
Oh, it does? All right. That's good. I like that. So anyway, so basically, Taylor series, Riemann sums, trapezoidal rules, those are all approximations. The Riemann sums and trapezoidal rules for AB are approximations of area, and for BC, you don't have to worry about Simpson's rule. That's another approximation of area.
And also, what if we have a decimal for like the natural log of 9? How would we do that?
Natural log of 9?
Or something?
You could leave the answer to be natural log of 9, or you'd do it 3 decimal places.
Do we have to put approximate?
Oh, no. That's a great question. Let's show you what you're talking about here. That's very Cindy Marcon. Where are you going to school? You already told me where you're going to school. Where are you going to school?
Oh, where am I going to school?
Yeah.
Hopefully University of Jacksonville, Florida.
That's a great question, what you just asked. Now, you said that if the answer is natural log of 9, should you put approximately 2.197 or 2.197? Either way, you would get full credit. They're not going to be that picky.
Okay.
That is a great question. A fine question. Can we have a bell? Is Angela Carter out there?
Yeah.
That's the bell. That was the bell for her because she's in the room.
Okay.
All right. What else what other questions? Let's just keep talking. Is that all
the
for
power
now?
series.
What's that?
What about the power series?
Power series,
Oh.
same thing as Taylor series, approximations. Okay? Hey,
Audrey wants to talk to you.
okay, we're
Mr. Fry?
yeah, hi Audrey.
Hello.
You sound hoarse. What's going on?
I wanted to know if it asked to generate the Taylor series for like natural log of x. Do you have to generate it, or can you just use the memorized power
Oh,
series?
absolutely memorize those. On the BC formula sheets, I think it's like formulas like 35 through 41 or something. Absolutely. If you have to memorize one thing, it's memorize those 6 things and then manipulate the series like that for the BC stuff.
So you don't have to show how you
No,
did it if it says to generate? Okay.
no, absolutely not. You would write down the general term like you'd say, e to the x is this, so e to the x squared is blank. But
Okay.
you'd write down that. That's a great question.
Okay.
Hey, call in again. You going to be there Saturday, by the way?
Yes.
Okay, great. I'll see you Saturday. Call in again, okay?
Bye.
Jermaine Martin?
Yeah, Mr. Fleischer, how you doing?
Hey, Jermaine, are you coming to the administration building tonight?
Yes, I am.
You are? Okay, I'm going to see you tonight because you're a National Achievement Scholar. Let's show you a picture here. A senior.
And David.
And David's coming too?
And Booker.
That's right. I was going to see you. Hey! National Achievement Scholar. It's a fine looking picture. Hey, Jermaine? Hey, Jermaine?
Yeah?
Remember when I saw you in Schlotsky's that one day?
Yeah.
That's right, okay. I got a problem for you, Jermaine. How's it going?
Oh, it's going all right.
Hey, let's go with that problem that Mary from W.T. White was doing. She came up, well, I guess you can't see that, but she came up with this. This was the same problem. Were you doing this problem with her when it was up a couple minutes ago?
No, I wasn't.
Jermaine?
I just walked in.
Okay. Well, she found that the velocity was equal to 3t squared minus 18t, was it plus 24, is that right? Plus 24. Okay, and now part B in the same problem says, for what values of t is the particle at rest? When is it resting?
When it's equal to 0.
When what equals 0?
T. When VT. When that. When velocity equals 0.
Just like today. You know, that's really important, Jermaine. I'm glad you said that because you said when it is equal to 0. No, that's fine. That's great. I mean, you're doing great. On the AP exam, you have to write down, if you wrote down just this would get you a point because it tells you that you know when the velocity is equal to 0. So you write that down. You show them, hey, I know what I'm talking about. And then you do this, and without a calculator, Mr. Algebra, you set this equal 0, and what would you do? The great Jermaine Martin, National Achievement Scholar.
Well, let me get a little bit closer to the screen here. Okay. You would start off by, I would take a 3 out myself.
I would take a 3 out myself, too.
So it's going to be 3 times t, the quantity t squared, minus 6t. Minus 6t.
Okay.
Plus 8.
And then what do we do?
Equals 0. Okay. Now, I know you got a factor. I'm trying to see what the factoring is. It's going to be... when you factor, it's going to come out to be, what is that? Oh, negative 2. It's going to be t minus 2 and t minus 4. There we go.
Excellent. Right. So therefore, when's the particle at rest, Jermaine?
The particle at t equals 2/3.
What?
T equals 2 and t equals 4.
Right. So you get point for % equals 0 and a point for the answer, okay?
Okay.
So you get a point if you put down that, but show them that you actually know it's when, you can actually write out particles at rest when velocity is 0, or you could just put down that, and that's how you get points. If you just sort of wrote down t equals 2 and t equals 4 because you could do this all in your head, you'd only get one of the 2 points. You have to tell them that you know that the velocity is equal to 0.
Okay.
Isn't that exciting, Jermaine?
Yeah.
Hey, call in again and I'm going to see you in a little bit, okay?
Mr. Fleischer.
Yes, sir.
Some friends, the class wants to see my picture again.
Class wants to see your picture again? Okay. Here we go. We're going to... There he is, Jermaine! In the tux. Okay.
All right, see you tonight, Mr. Fleischer.
Okay, you got it, Jermaine. And David and Booker. Martine. Jaguars. Jaguars. What's going on?
Oh, nothing.
Oh, nothing? Hey, let's continue doing that problem, okay?
Oh no. Okay, yeah.
Is that too easy for you?
Mm,
It is too easy for you? Okay, I'll give you
No,
another
it's
problem. then. I'll give you another problem. Yeah, we're going to get to that total distance too. I like it. Bump it up and divide. I like that. Bump it up and divide. Bump it up.
that's it, man.
Jane, we could do a rap. Bump it up. Okay. All right. Hey, Martine,
Mhm.
I'm looking for your picture. You see
Oh,
that?
no.
This is the graph of f prime.
Okay.
Okay, for what values of x does f have a relative maximum? Tell me what you would do if this was an AP exam question, which it was, and
Well, I'll write it just like f has a relative maximum when the first derivative changes from positive to negative. That would be in -2.
so I want you to tell me exactly this is the AP exam.
Okay, f has a relative maximum.
So you'd say f has a rel max, and you could actually abbreviate if you
Yeah.
want. F has a rel max
When the first derivative changes from positive to negative.
when the first derivative, and you could actually just say when f prime changes
Mm-hmm.
from, you could abbreviate from pos to neg or plus to minus. That's fine.
Okay.
Okay, and so then what would you do?
And that'll be a -2.
That would be -2. This would be full credit, 2 points. 2 points. Hoop it. 2 points, holding the Jaguar. Okay. Hey, and you know what you also could do, Martine?
Mm-hmm.
You could actually show this chart. In case you're not confident, which you were confident, of what you're writing down, you could actually show this chart that is full justification on doing this. You could say f prime is positive, negative, negative, positive. So f is increasing, decreasing, decreasing, increasing, and then write down. This shows you that you know that this shows you that you were able to explain what you're trying to say.
Yeah.
Hey, that's a
Okay.
great job.
Mm-hmm.
Okay, call in again, all right, Martine?
Yep.
You're going to be there Saturday, right? I already hung up. Sorry. Quentin Neely?
Yeah,
What's going on?
not much.
Connor Cowboys?
Yes, sir.
Has Valina calmed down?
Yeah, she calmed down.
Okay, here you go, Quentin.
Oh, Miss Brent said, "What's
This is, this is a, we have sponsors. We have to pay them, but we have sponsors. Okay, anyway, all right, same, part B of this question. I think this was 1996, number 1, free response number 1. For what values of x does f have a relative minimum? What would you do if this was the AP exam question?
Okay.
Quentin, the great Quentin Neely.
You would have
We're gonna after you do this, we're gonna have our studio audience, see if she agrees with you.
okay.
Okay. Oh, but she can't hear you, so. But I'll write it down. Okay.
Okay.
Go ahead, Quentin.
When it changes from negative to positive, you have
Wait. You said a bad word. You know what bad word you said? You said it.
it. Okay.
Never say it.
When the graph changes from negative to positive.
What graph?
When the graph of f prime of x.
Ding 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 ding. Right, that's correct. It's when f prime
of x.
changes from negative to positive. So what's the answer?
The answer would be 4.
It would be
X
4.
is 4.
Let's ask Jane Lilly if you agree with Quentin Neely. Jane, do you agree that the answer is 4?
That is definitely correct.
I'll tell you, we're really very. Quentin, this is why we have trouble with our sponsorship. Anyway, f prime, right, you could show the same chart that you showed before. I don't know what I did with it. I think it's on the back side. There it is. You could show the same chart for part B, and you could just put x is equal to -4, or x is equal to 4.
Right.
Or you could actually write out. Now, Quentin, I would recommend you showing this chart because you have a tendency, like a lot of students, and it's not bad, to say you know what the answer is, but you don't know how to phrase it. So you could use this terminology, this notation to get full credit. Because if you would say f has a relative min when it changes, you would not get credit for the justification. Okay? You'd have to say when f prime changes from negative to positive.
Okay.
Hey, Quentin, great job.
Thanks.
Who's next? Hello? Jennifer who?
Hello.
Hello?
Hello.
Hi, who is
Hi.
this? Jennifer?
Jennifer.
Jennifer?
From Brian Adams.
Jennifer, oh, Jennifer Plunk?
Yeah.
Hey, do we have that the calculus song queued up? Do we have it anywhere around, Delbert? We have Lyle Lovett, but we don't. Lyle Lovett?
Miss Arthur says you're wasting time.
I'm wasting time. Miss Arthur. Miss Arthur's very concerned about what I do, I'll tell you. Okay, fine. Okay, at what interval is a graph of f concave up? Use f prime to justify your answer. This is f prime.
Okay.
When is f concave up?
When F double slope
When f double slope?
is
I like that, f double slope.
change is positive. Yeah.
Okay, very good. In general, f is concave up because you know you've been studying your formula sheet, right? You've been sleeping with your formula sheet, right?
I don't know what you're talking about.
You don't know what the formula sheet is?
No.
Wait. Well, Miss Arthur. Miss
The
Arthur.
12 things you mean?
The 12. That's part
Yeah,
of.
I know that.
Okay. There's 12. There's 3 pages. 12 things. Okay. Anyway, Jennifer. So you're right. It's if you look at, it's when f double prime is positive, but it says use f prime to justify our answer when f is concave up.
Or when F prime is I don't know. I know there's another one. You know, you can do it by the slope, but I know the double slope. So
Okay, we know it. Don't say double slope. Say f double prime. I mean, it's you could say anything you want, but don't write that down.
Oh, I would like F double little.
F double little. Okay, so f prime. If this is f prime, the slopes of f prime are f double slope. I mean f double prime. So therefore, the slopes, when f prime is increasing, the slopes of f prime or f double prime is positive. So the correct answer would be.
Oh, what's my answer?
The correct answer would be to when you write this down, when f double prime is positive, when f prime is increasing.
Increasing. Okay, so then it's like from -1 to 1, and then what's 3? Okay, yeah, 3 to 4 or 3 to 5 actually.
Yeah, now this is something interesting. Usually on the AP exam, you get credits for brackets or parentheses. In this case, you would not get credit if you use brackets. For concavity, it's just semantics, but actually it's the definition of concavity. For concavity, you have to use parentheses. So when in doubt, just use
Could you just write it out like from
You sure
-1
can.
to 1?
That would be great, but then don't use an equal sign then.
Yeah, I wouldn't.
Okay. And usually you get credit either way, but in this case, it's not like that. Okay, so that would be full credit. Or what you also could have done, Jennifer, you could have shown this. F double prime, F prime is increasing, so that means F double prime is positive, which means the concavity of F is up. And you could have done that from 3 to 5. You could have shown this little chart. And you could, this is down, then up. You could have shown this, but quite frankly, it's easier just to write that out, right? Great job. Fine job, Miss Plunk.
Okay, thank you.
You're welcome. Preeti Ratikanda.
Hey, Mr. Fleischer.
How you doing? What's going on?
Nothing. I was going to ask you a question about
Ask me a question. That's good. Ask me a question.
Wait, previous one. You said you can't put a equal sign
Yeah.
when it's a concave.
That's correct.
Concavity.
Yeah.
Okay, but you can put an equal sign. For
Yeah, but
everything
just
else?
don't ever put an equal sign. It's just simpler that way. You get credit all the time if you don't put an equal sign.
Okay.
And for increasing and decreasing. Okay.
And always put parentheses.
Right. Right.
All
Don't.
right.
Which means that's what it means.
Okay.
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 Boy, I got to give you a hard problem. I don't have any problem. I'm gonna have to make one up.
Oh.
Okay, Preeti. Here we go.
Okay.
No pressure here. How about this? 1 to 2.
I thought you were gonna do for response.
Well, this is for you. We're doing a little different. Okay.
Okay, you separate them, right?
You can't fool Preeti. All right, go ahead.
You separate them, x over x cubed, integral of 1 to 2, yeah, minus x squared over x cubed.
Okay, then what do you do?
You would subtract the top from the bottom, right?
Tell me what to write down.
I guess x to the negative 2
Okay.
and x to the negative 1.
Okay, now what do I do?
You take the integral of, you add, so it'd be x to the negative 1. The integral of x to the negative 2 is x to the negative 1 over negative 1.
So it's x to the negative 1 over negative
Yeah.
1, or negative 1 over x.
Yeah.
What's the integral of x to the negative 1?
Natural log of x.
Ooh, Preeti, she's in fire. She's en fuego. En fuego.
All right, you plug in 2 and 1, so negative a half
You're almost there. Don't choke.
minus natural log of 2
Okay.
minus 1,
It's minus negative 1.
oh, negative 1. And natural log of 1 is 0.
Very good. Okay. So from there, you add 1, and you get negative natural log of 2 plus 1/2, right?
Yeah.
It's a fine job. Fine job, Preeti.
You're not going to take off points for that
I don't
negative
know.
1,
I
are
don't know.
you?
We'll have to talk about that point system here.
All right.
Preeti's a wonderful student at Hillcrest who loves to get extra credit.
Do you want to give me another problem? Mr.
No, well, call in again. We got a couple people waiting. Okay.
Okay, all right.
All right.
Bye.
Thanks, Preeti. Hey, Jane, we're going to do a duet. Cecilia's on the phone. Okay. Cecilia,
Yes.
we're gonna sing a duet for you, right? Cecilia, you're breaking my heart.
You're breaking my heart.
Okay, oh, that's great. Hey, Cecilia,
Yeah.
what do you think? What do you think about my singing future?
Love it.
Did you say Lyle Lovett? I sound like Lyle Lovett?
What?
That's pretty cool.
Repeat. I didn't hear it. I love it.
Cecilia. Yeah, that's right. There you go. Okay. All right. PG. All right, here we go. Cecilia, we're going back with the problem that I was going to give Martine. And we found out in part A, in this problem, we found out that the velocity was equal to 3t squared minus 18t plus 24, right? Okay, and then we found the particle at rest, and the great Jermaine Martin told us that t equals 2 and t equals 4. How would we find, Cecilia, no problem. You coming this Saturday?
Yes.
How would we find the position?
Okay. Let me.
How would we find the position?
Integrate the velocity.
Integrate the velocity. That's right. What you would do is you'd actually just show that the position is equal to the integral of the velocity, right? You may get a point just for putting that down. So from there, you have the integral of the velocity.
Floppy, got your DT.
Who said that? Now, that's a good question, a good point, because on the AP exam, they would not take off a point if you forgot the DT. But you're right, it is. No, they wouldn't. They really wouldn't. No, seriously, they wouldn't. But that's it. It is good to put that on there because it represents the infinitely. It represents the infinitely thin thickness of the little billions of rectangles you're adding. So you should put it on there, but they would not take off a point, I promise, if you left it off. All right, and here we go. So what would you do? What's the integral?
T cubed over 3.
So tell me, talk to me.
cubed.
Cecilia. Oh, I'm sorry, did you say that?
Yeah, T
Okay.
cubed over 3.
It's 3t cubed over 3, which is just t cubed.
Okay. Minus 18t squared, which is 9t squared.
18t squared over 2 plus 24t
24t plus c.
plus c. So it's t cubed
Minus 9t squared.
minus 9t squared
Plus 24t
plus
C.
24t plus c. Now what do we do?
Plug in the 20. So the 20.
Yeah, plug in
one.
20 for the position. So you
20.
get a point for this and a point for 1 minus 9 plus 24
Plus c.
plus c, and then you solve for that, you get negative 8, You got 16.
16.
So we got
4.
C is equal to 4, right?
Uh-huh. Yes.
So we got the final answer would be t cubed minus
Minus
9t squared plus
24
24t plus 4, right?
Uh-huh.
Okay, that's great, Cecilia. Hey, okay, we'll see you this Saturday, all right?
Okay.
Hey, Delbert, how much time do we have left? Oh, we got plenty of time. Is this a great Booker Law?
Hello?
Hey, Booker?
Yeah.
We're going to sort of do a joint problem with you and Jane.
Okay.
Okay, do you remember? Actually, Jane's a junior at Woodrow. We caught her walking around the halls of the studio, so we brought her on the show.
Okay.
Jane, why don't you wave to Booker?
Hello.
Hello, Jane.
How are you?
Okay.
I don't think I have your picture, Booker. But anyway, okay. Well, let me put the problem up. It's going to be a joint problem. Isn't this exciting? This is like, I'm so excited I can barely contain myself. Booker?
Yes.
Same problem that we've been doing. We're going to find the total distance traveled from t equals 1 to t equals 3. And this is what we know. We found out that the position in part C, what was the position? T cubed
Minus 9t squared plus 24t plus 4.
All right.
Okay, and the velocity was equal to
3t squared minus 18t.
right. Oh, you're a step ahead of me. 3t squared minus 18t
Plus 24.
plus 24. Okay. So Booker, you start out. Total distance traveled. Let's do this without a calculator.
Okay.
What are you thinking about?
It's the integral from 1 to 3.
The integral from 1 to 3. Okay. If the integral 1 to 3 of what? What are we going to integrate? The velocity.
The integral of 1 to 3 from 1 to 3 of the velocity.
Okay, first of all, before we start, we knew that the particle was at rest. The particle was at rest. The velocity was equal to 0 at t equals 2 and t equals 4.
Exactly.
Hey, Booker, if we just integrate the velocity from 1 to 3, what you would get would be the change in position.
Okay.
Now, Booker, let's say you travel to when you integrate the velocity, you get the position. And then you plug in 3, you subtract, you plug in 1.
Be quiet.
So you would just get the change in position at... You get the change in position at, which would be just your displacement. Because it's like, if you, let's say, travel to Waco, 100 miles, and come back to Dallas, in a matter of 4 hours, your change in position is 0, but you traveled a total of 200 miles.
Yeah.
So we don't just integrate the velocity. We do something. We do something else. Jane, do you want to try to take a stab at it?
Probably going to separate.
Okay, what you're going to have to do is split it up into 2 different integrals.
And that's what Booker. That's what you just said right there, right?
Yeah.
Okay. Now, now Booker, if the velocity is equal to, if the velocity is, what was it? It was at 3. The velocity was positive, right?
At 3, the velocity.
If you plug in 3, 27 minus 54, it was actually negative then positive. Okay. So the velocity, it turned out from 1 to 3, from 1 to 2 the velocity was positive, and from 2 to 3 the velocity was negative.
Right.
Okay. So how would we split up the integrals?
Well, you split them up according to 1 to 2 and 2 to 3.
Right. And we would subtract the ones from 2 to 3. We would subtract the 1 from 2 to 3 because that's where it's negative.
Right.
And that's what you want to do. You want to take where the velocity is positive and subtract out where it's negative.
Right.
And I'm not going to actually go through and do this, but you would actually, this is, if you had a calculator, then you actually write down the velocity function and integrate it. But if you had a calculator, what would be another way to do it even more quickly on the calculator? What do you think, Booker?
You could integrate from, wait, let me think about it for a moment.
Okay.
I'm not sure.
Okay, Jane, if you had a calculator, do you know a quicker way to do it than separate into two integrals?
No, I have no idea.
Okay, one thing you could do is you could take, right, very good, Booker. You could take the absolute value of the velocity. In y sub 1, you could take, because where it's negative, it'll just pop up. Where it's positive, it'll just be the area under there. So in y sub 1, you could do the absolute value of the velocity and then just integrate that from 1 to 3. That's if you only had a calculator. But either way, on the AP exam, make sure you set up the integral so you know, so the reader knows exactly what you are grading, okay?
Okay.
Hey, Booker, great job. We'll see you in about an hour.
All right.
Okay.
All right.
Hey, who's next? Great job, Jane.
Me.
Tasha?
Yes.
Tasha,
Yes, I'm here.
how you doing?
I'm fine, and you?
I'm fine. What type of problem you want?
Easy one.
Okay, all I have is this left.
Oh, hi, Booker.
Hi, Booker. That's right. You, how do you know Booker?
I went to Atwell with him.
That's right. That's right. And you know, before you were talking to Giovanni, you're talking to Booker. Remember Tasha? You know, I'll tell you. Okay. No calculator. F of x is equal x cubed minus 5x squared plus 3x plus k.
Okay, when is on what intervals is it increasing? First, you're gonna find the derivative, and that would be x squared minus 10x plus.
What's the derivative?
Oh, I'm sorry, 3x squared
Okay.
minus 10x plus 3.
You get a point if you wrote down. If you point if you write down this. Okay, keep going.
Okay, then you set it equal to 0.
Set it equals 0. Okay. And then what do you do?
Factor out 3.
Well, 3 doesn't.
Factor, just factor, yeah. Yeah. You can't factor that. No, okay. Okay, if you factor it, then it would be, just a second. It would be 3x minus 1 times x minus 3.
Very good. 3x. Wow, that's pretty good.
Yay, good job.
And if you didn't know how to do this, if you didn't know how to factor,
And
what could you do if you didn't have a calculator and you didn't know how to factor?
you made a mistake, Mr. Fleischers.
Oh, I
said
did?
x minus 3.
What is it?
3x minus 1 times x minus 3.
Oh yeah, just it was a mistake. It was a misprint.
Okay, yeah, misprint. Okay, and then you said each one equal to 0.
Okay, and then so what's the answer?
I
Answers.
don't know, I'm still working. Okay, that's gonna be 1/3 and 3. X.
Right. So
know, we gotta
therefore
do this
those and what are those things called?
Those are critical points.
Okay. Now if you didn't, wait, hold on, Tasha, slow up for 1 second. If you didn't know how to factor and you didn't have a calculator, what's another way you could have solved this?
I don't know. Good question. Could I have factored out
Quadratic
3?
formula. Quadratic formula.
Oh, what formula?
Okay.
Quadratic. Oh,
Hey, Tasha,
I didn't want to
and
say
then
it,
from here you're going to do this number line thing that Miss Blackwell taught you.
the test.
And if you plug in 1, you have a positive times a negative. You plug in 5,
Right.
positive, positive. Plug in 0, negative, negative. So that means
So it's increasing where it's positive. So it's between, is it negative infinity to 3? And no, it's 1/3. And then from 3 to infinity.
right. Now, you would not get a point if you put brackets or around an equal sign around the infinity. If you put brackets there or parentheses, it doesn't matter. But make sure you put parentheses always. It's safer. Okay?
Okay.
And this would be full justification. You get full 3 points for
So I
that.
get a full 3 points on all
Well,
of
Tasha,
that.
you going to be there Saturday?
Huh?
You going to be there Saturday?
Yes, sorry I can't take your class. Prom is Saturday.
That's okay. Promise I'll prom.
Yeah. I'll be there to see you, though.
Okay. All right. Well, stop by and say hi, okay?
Okay.
Hey, good luck, y'all. We got 2 weeks left. Jane, thank you very much for stopping by and helping us with the show today.
No problem.
And 2 weeks, baby, 2 weeks. See you next week. See you Saturday. Bye.
She hates my mama. She hates my daddy too. She loves to tell me she hates the things I do. She loves to laugh beside me almost every night. Well, she's no lady, she's my wife. The preacher asked her, and she said, I do. The preacher asked me, and she said, yes, he does too. The preacher said, I pronounce you 99 too late. Son, she's no lady, she's your